All right, hello everyone. Welcome to a presentation. So I want to start this off by asking you guys a question. When you're making some technology, you're working away, you're programming, do you ever think to yourself, man, this is going really great, but I just wish this was more complicated? Hopefully not. Hopefully we can all agree that simple is, well, perhaps not necessarily better than complex, but at least more preferable. We like to keep things simple. And that's really what we're going to be talking about today. The beauty of simplicity, making your own technology. Wait, did I write simplicity? That doesn't sound very simple. So I want to talk today about how, a lot of the times we're somewhat pressured to pick existing solutions rather than making our own, and how, if you go that route of making your own technology, how I guess simplicity is like really important to that core process. So a little bit about me. So hi everyone, my name is Jan. Thank you all for coming to my talk, and thank you YOW as well for having me. This is my first YOW. I'm very happy to be here. Some of you might know me as Cherno or the Cherno, because I have a YouTube channel where I make videos, mostly educational programming videos. I share projects that I'm working on. I also have like this code review series where people send me their code and I take a look at it, give some advice. And then I'm perhaps best known for this C++ series where I teach C++. So before I became like an internet person, I had a real job. I used to work as a software engineer at EA on game engines. So who here knows what a game engine is? Cool. So for those of you who don't, it's basically like the platform that you use to build games. So it's both like the tool side that the developers use to actually make the games, and also the runtime, what's called a runtime, which is what the game actually runs on people's devices. So I worked on this game engine called Osiris, which was like EA's primary mobile game engine. And then later, we moved on to Frostbite, and we became Frostbite Melbourne. So those of you who have been to Melbourne might have heard of this area in the city called the Docklands. It's like this ghost town. No one really goes there, but that's where I worked. And then I left in 2019. And I left because once we kind of moved on to Frostbite, things started getting a little bit more complicated. And one thing you'll learn about me in this talk is I don't really like complicated things. And I think it's just like the consequence, of course, of working on such a large product and such a large organization meant that it was very process-driven, very slow to make actual like real changes to the code base. And I started working at EA when I was just 20 years old. It was like my first job out of uni, and I really wanted to take some time to process everything that I had learned by being thrown into the deep end, and try and maybe build my own game engine, because that way I would understand everything. And YouTube was doing fairly well at the time, so I thought I'd give it a go and leave. And so now I'm building this engine called Hazel and making YouTube videos full-time. Okay, so I want to talk a little bit about Hazel, because the core of this talk really is about everything that I've learned by working on this thing. So Hazel is a 3D game engine. This is what it looks like. I started working on it about 5 years ago, initially by myself, but then because I was making YouTube videos about it, a community formed, and people started volunteering to like help out on certain systems that they were interested in. And we grew our team to around 8, I think, including myself was like the maximum team size. And I ended up hiring some people, and this is what we made. And we're still working on it. I like to say that working on a game engine is a lot like art. Like, it's never really finished. There's always new features you can add, new technologies coming out. And so you just keep working on it perpetually. And when I mention that I'm working on a game engine and I'm building my own, this is the #1 question that I get. Why? Why would you do that? Don't game engines already exist? Isn't that like really hard? So I could talk for 40 minutes about why, but I'll try and be brief here. So basically, the first point here is that I just really like game engines. When I was growing up, I would play these games, and I would be way more interested in the technology behind them than the games themselves. Like, how do they make that happen? And I think they're a really cool technical challenge as well, because game engines are just like this collection of all these different systems that have to work together. So anything you're interested in, like AI, rendering, audio, like it's all kind of there, and it all has to work together inside this like massive system. That coupled with like really tight performance constraints, as well as like it has to run on a variety of different hardware, meant that it was just really cool to try and solve something like this. I also wanted to use it as a prop for my educational videos. So like when I'm teaching C++, there's only so far I think you can get with, here's a CPP file with a few lines of code to demonstrate this concept. It's nice to have a real world example that I can be like, okay, this is why we do things this way in the real world. And then finally, like I did want to make a game eventually with it. That wasn't the primary goal, but that was something I wanted to do. And I kind of see games as like works of art. And I guess for me, it was important for, like the technology was part of that art, you know? And so I wanted to make a game with my own technology because that was just, I guess, my artistic method. Like artists have various like methods and mediums that they use when they produce their art. And I guess mine was pain. So we have made a few games. So this is an example of a game we made 2 years ago called Dichotomy. We made this in like 3 days for a game jam. Here's some gameplay. It's like this little puzzle game. You have to play out some moves in this blue sandbox, and then it replays what you've done in the real world where you can actually see what you've done. Let me just pause that so it's not too distracting. So this specifically, why I bring this up is because this was a huge milestone for us. Because up until this moment, we were working on this game engine with no real expectations of like finishing it or getting it to a state where we could make games. Because you know, there were no like investors that we needed to meet deadlines for. It was just something we were doing for fun. And it was fulfilling its purpose in the sense that it was driving my content on YouTube. And I was able to use it to teach C++ and game engines. But then one day, I just remember waking up in the morning, and I was like, okay, well, I have to do this and that today. And then if I do that, I can kind of use this now to make a game and ship it. All the pieces are just there. And that was like literally a surprise to me. And I think, you know, I compare this a little bit to running a marathon, which I've never actually done. So we'll call this a thought experiment. Pretend you're running a marathon, and it just seems like, you know, it's so daunting. There's such a large distance for you to run. But if you just keep moving forward, you just don't look at the finish line, like let's just head down, move forward. As long as you're moving in the right direction, you're getting closer to your goal. And then one day, hopefully, you'll look up, and you'll either be in the hospital or you'll see the finish line, hopefully. And so now that I had come out of the other side and I'd made this technology that was actually capable of doing its purpose, I was able to reflect on that and be like, okay, well, was this really as hard as I thought it would be now that I've seen everything and I've gone through it, you know, firsthand? And that, I want everyone to think about that as well. When you're working on something and you've come out the other side, let's reflect back on it. Was it really that hard? So let's talk a little bit about how we achieved this state, I guess, of being in a position where we can actually make what we want. So first of all, it's simple, and that's not a choice, meaning like the technology has to be simple. You have to keep it simple because you're forced to work within pretty serious like limitations, and you have to make sacrifices, meaning you can't just make something that does everything. You have to stick to a particular path. And so like it's a little bit like working smarter versus harder. The reason why I wrote in a way is because really it's both. You have to work smart and you have to work hard. You can't just do one of them. It's like the worst of both worlds. And the reason why you can't just work hard is because you can't just brute force a solution by throwing more resources at it. You just don't have those resources, you know, to keep throwing at it. Delegating and outsourcing is a huge part of this as well, which we will focus on later as well. And then you have to always keep asking yourself as well, is it really as hard as it seems? Like, can I just do this the simple way and maybe that will be enough, maybe that will just work? Because I think humans in general just have a way of overcomplicating things. And I want to explore this concept of simplicity, right? Because a lot of people might see, like, okay, it's simple as a downside. Oh, it doesn't do everything. But let's have a look at an example at where simplicity might actually be an upside. The Unity game engine. So who here has heard of Unity or used Unity? Oh, wow, lots of you. Cool. More than Melbourne. I like you guys. You're going to all switch to Hazel by the end of this talk. Okay, so I've got this like really simple scene over here where we just got like a cube and it's got some physics on it. Now, I want you to just pay attention to how long it takes once I hit that play button for the scene to actually start playing. Right, so super simple scene. Let's hit play. All right, and then let me just do it again so you can see it's not like a first time running thing. This is the latest version of Unity. I downloaded this like last week. Okay, let's add some behavior in C#, right? So I'm just going to add like this thing that happens when there's a collision. It'll add like an impulse force. So I got to go back. It's got to compile and process my scripts, which takes a while. And then I got to hit play. And I'm kind of just stuck in this like, I guess, position of just waiting around for stuff to happen because of that extra overhead and complexity of Unity. And so for this little solution that I'm working on, I'm kind of suffering because of Unity. So is this a good solution? Is Unity a good solution for this little problem that I have? Well, let's have a look at a more simple example. So this is Hazel, same exact scene. A couple lights, like a ground plane, a camera, and this. And I want you guys to just, basically when I hit play in a minute, just time how long it takes once I hit play for the scene to start playing. All right, so that was pretty quick. And then if we do the same thing and we add some behavior using C#, which just adds a little bit of complexity, it's a little bit different. You have to add like this event action with Hazel's API, but we're still adding that impulse force. I'm going to first of all compile it through Visual Studio, which according to that log took 0.7 seconds. And by the time I Alt-Tab back, it's just reloaded my C# DLL, and I can just run everything, right? So you can see that, because Hazel is much more simple, we're able to have this like frictionless workflow, basically. And of course, we're not trying to compete with Unity. Unity is doing a lot more, and it can do a lot more, and it can solve way more problems than Hazel can. But it's just to like think about that aspect of like, okay, well, if this is simple, it might actually be a benefit. So is Hazel a better solution to this problem than Unity? Well, I mean, I'd probably say yes. However, of course, you have to consider the cost. Like, if you built this thing and, for example, it took you 5 years and $10 million, then maybe you'd be OK with waiting a few seconds for Unity and paying a few $1,000s in licensing fees. And so the overview of what we're going to talk about for the rest of today is basically this concept of picking an existing solution versus building our own out of like these building blocks. So the first thing I want to talk about is, why do we even use existing solutions, and what are they? So an existing solution is just like an exact product, I guess, that does what you need it to, in the sense that it solves your problem. So a game engine is an example of an existing solution for the problem of making a game, but really this applies to any industry and field. So for example, if you're a web developer, maybe you need to make a website for a client, and they want it to be like dynamic, and they want to log in, make some posts, post some images. WordPress might be an example of an existing solution to their problem. And for the rest of this talk as well, I'm going to keep drawing the example of game engines because that's my industry, but I want you guys to just kind of translate that into your industry and field because it should translate pretty well. So I think it comes down a lot to business decisions. I think, those of us who are engineers, if we were given the task of solving a problem, I think we'd probably be okay. In fact, we prefer to just make our own solution because that's fun, we can do it better. But of course, we live in the real world, so we have to be, we have to constrain ourselves with like a budget or a time frame. And so picking an existing solution will make it easier in that sense. So let's use Unreal Engine as an example for this existing solution and the benefits. So first of all, what's the cost? So Unreal Engine costs 5% of your gross revenue above $1 million US. Can we compete with that? Well, Unreal Engine started in 1998. It's been worked on by thousands of people since then. It's been tried and tested in the sense that many games, many titles have shipped with it on all these different devices. And also, it comes with like this future maintenance. So it's not just like you get the product and that's it. The licensing cost you're paying includes further development and updates and bug fixes and everything. There's also like this hidden cost, like existing skills. So what I mean by that is because it's been around for like 26 years and it's public, there's obviously like in the job market, there's lots of people who know how to use it. And that means that if you need someone and you can hire someone, they're going to be already ready basically to use it. So we had like this problem at Frostbite, at EA, that Frostbite is like an internal engine. So if we hire someone, unless they've worked at EA before, they don't know how to use it. And so we have to train them up, and that might cost like 6 months of time. So that's another benefit of choosing an existing solution. And so what you're really doing is you're outsourcing that, of course, to a third party. And then how much would it cost to do this ourselves if we didn't want to outsource this? Well, I'll answer that for you. An infinite amount of money. Because you need a time machine to go all the way back to 1998 and build this thing. Okay, so it seems pretty bleak. Why wouldn't you use an existing solution? So I think it also comes down to business decisions, but for them, right? So they are also a business. Their goals are different to yours. They're making a product. They want it to be successful. So of course, they want to draw in as many customers as possible, and they do that by casting this wide net. Their product is great for everyone. But then that leads to complex and unnecessary software. So just to paint you an example, you might be making a 2D PC game, but Unreal Engine could make a 3D first-person shooter on an Android phone. It's completely different, but yet you've got that, and all the pipelines have to work together for all of that in your example that completely doesn't benefit you at all, and in fact might actually lead to slower products. They're also often black box, these existing solutions. Not in the case of Unreal Engine, that's source available, which is great. But you often don't have the source code, they just provide you with binaries. And that means that, what if there's a bug? What if we need to support another platform or architecture or API? We're reliant on them to do that for us. And so it creates a strong dependency. And to give an example of that, I'm going to use Unity. So some of you may have heard, about a year ago, Unity tried to introduce this thing called a runtime fee. Has anyone heard of this? Yeah. So they tried to charge I think it was I don't know the exact numbers, but something around 50 cents per install. So every time someone installs a game, the developer would get charged 50 cents. And people were outraged, and they were well, first of all, what's an install? What if someone just continually is running out of disk space and they keep deleting and then installing the game again? Do I have to pay every time? What if they have 3 different devices? Is that $1.50? How are you tracking this? What's the privacy like? And so they went back on that. But you don't need to look a year back to see what Unity has done, because this was posted on Reddit last week. So basically, this indie game studio had released their game on Steam, and then their Unity accounts just got suspended. And the compliance team was sure, we can take a look at this in 2 months. And so they were basically stuck in this position where they couldn't actually access the product that they had made, which is crazy. And someone commented this, which I think is pretty accurate. And I guess I like to sum up this situation like this. And that's really the problem with all of these dependencies. And of course, I don't think people choose to be dependent on a third party. It's just because of those business decisions or because of timeframes, it ends up being like that. And so I want all of us to consider this concept here. If you could build your own custom solution from scratch, would that be better? And the answer might be no. That's totally OK. But let's just explore this concept. So first of all, from scratch. What do I mean by from scratch? Making your own fire? Making your own CPU? I think people, look at from scratch as this really, really impossible task. And a lot of people like to joke about it as well. Are you building something from scratch? What, are you going to make your own operating system? But what do I mean in the context of this talk when I say, let's build something from scratch? I'll explain through a series of jokes. So does anyone know what this is? I like that so many of you are actually saying it, because Melbourne was dead silent. I'm do you guys not know what this is? So I like to call this modern software development, where this is our code, and these are libraries or frameworks. So I found this on Wikipedia. So basically, this little filing cabinet over here is this library. It's a bunch of code, basically, a bunch of subroutines punched in. We've got these tapes here. What she's doing, as far as I understand, is she's feeding it through this machine here in the middle that, I guess, lets her see it. And then she's copying it down into her own program. So she's literally taking code from libraries and copying it. And this is back in the 50s. So not much has changed. Are there any web developers here? Cool. So you probably would be familiar with frameworks and libraries. All right, one more for the web developers. OK, I'm sorry, web developers, I'll stop. This concludes our little comedy intermission. So has anyone heard of GitHub? So it turns out there's a lot of code on GitHub. How much? Well, over 5 billion developer contributions were made to more than 500 million open source projects in 2024. So over 500 million open source projects. So what does this mean for us? We feast. So from scratch, what do I mean? I mean, in this context, like, let's not pick the exact product that we need, the exact solution, but instead everything below that, everything that makes up this product that we need, we can be free to choose all of that. So Unreal Engine, for example, like in this third-party folder that they have in their repository, you can see they have lots of different directories here, and pretty much like most of them are third-party libraries. For a non-game engine example, here's Google Drive on iOS. If you go to like Help About, you can look at all the open source licenses and see what they're using. And of course, anyone who is a developer knows that, of course, we rely on so much open source software and all of these libraries. But I want to also draw attention to the fact that it's not, like these days, it's not really just like support libraries like, you know, a compression library or a data structure or like a job system. It's also entire systems. So if we break down Unreal Engine, you know, it's made up of all these different systems. I've just picked like these 4 randomly. And they're also made up of other systems, like rendering might have this rendering hardware interface layer. They're also going to have many support libraries, as I mentioned, like, you know, a compression library or a data structure or something. And so this like area here, these systems, why don't we just pick those? Because they're the building blocks that make up our application. So I want to focus on this layer of things. So that, like most of those, in our case, are going to be libraries and open source, because there's just so much open source code out there, and also knowledge, right? So if you ask someone 20 years ago, how do you render 3D graphics, like the answer you'll get today will be much more comprehensive. There's much more resources out there. And also, it's not just even resources available on the internet, it's also just the research that has gone into that industry has evolved so much, and it's just so developed. And again, not just support libraries on GitHub, but entire systems and middleware. So which a lot of them used to be paid or licensed or black box in the past. So an example from my industry is NVIDIA GameWorks. So that basically they have a bunch of these SDKs that can, for example, improve the graphics of your game. And they used to just provide this to you as like a DLL that's like, you know, you just plug this into your pipeline and your graphics will look better. But now, NVIDIA GameWorks is just open source, MIT licensed on GitHub. All the C++ code, all the shaders, they're all just there. So times have really changed. And this allows you to delegate and outsource a lot of those systems and things that you have to build your own technology, which I think is somewhat new. It's becoming more popular. And so, of course, because it is open source, it really allows you to kind of increase the resources of your team as if you had actually done it yourself, because in a way you get the same result. It allows you to crowdsource your technology. Whether that's a good thing or a bad thing, you can decide. But what I mean by that is, like, if something's public on GitHub, people are using it, they're probably contributing back to it, you know, pull requests, testing, of course. They might be using it in a variety of different products and doing much more than you could internally in your team. Maintenance as well going forward. So even if the original author disappears, if there's enough people using that library, then they'll have an interest to maintain it. And dev expertise, like usually people who write these libraries or systems, they're probably experts in them. Not necessarily, of course, there's a lot of code on GitHub. But there's just like, in the case of NVIDIA, you know, that's like a real company who are releasing open source software. And of course, lots of companies are doing that these days, right? EA have libraries on GitHub. Meta have libraries on GitHub. It's not necessarily just this like, you know, students pushing all of their code to GitHub. There's actually a lot of quality stuff on there, of course. And compared to doing it yourself, it might be a much better option. And so I see it a little bit as like the same thing as picking an existing solution, but finer grain. In the sense that you can make finer grain technical decisions on what you want to use. And we'll take a look at a real world example later. So think about, instead of just picking the exact solution, just consider picking the building blocks that make up that solution. Because of course they won't be black box if they're open source, right? Unlike some complete products, which means they're modifiable and examinable. But you have to also remember that, you know, despite all this, of course you still have to build the actual product. You're not just gluing these libraries together. The actual product you're building just sits on top of these libraries, and these are like just kind of outsourcing out those lower level systems. Okay, so let's take a look at a real-world example of what I mean by using these building blocks. So Hazel is also made up of a whole bunch of different systems. Here are 8 as an example. So if we have a look at what these building blocks looked like back in 2021, this is what they looked like. So we had like a few systems that we had the resources to and people were interested in writing them themselves, so they were custom. And then you can see the green ones here, we outsourced them to third-party libraries. Networking didn't actually exist in the world back then. And then so that changed over time as our needs changed. And so if we fast forward to today, it looks like this. So I've highlighted the changes here in red. So animation, like for skeletal animation, we decided we needed something a bit more powerful than that, a bit more custom. So we wrote something custom and we were able to focus on that. Scripting as well, we went from Mono to like a custom C# scripting engine sitting on top of .NET Core. Networking we adopted with Valve's game networking sockets library, and physics as well, we went from NVIDIA PhysX to Jolt because that just suited our needs better. Right, so we're able to go in and be like, okay, the parts of the solution I don't like, but I can just change those building blocks. It's all modular, I can just go in there and change it, whereas if we had picked an existing solution, like Hazel Engine up there, that didn't suit our needs, then of course we'd have to pivot entirely from that, and that could be much more disastrous and less customizable. So that's what I mean by this concept of we get to make finer grain technical decisions. And instead of picking the exact solution, we can pick the building blocks that make it up. And it allows us as well to focus our resources where required to produce a more specific solution, right? So if we go back a little bit, what I mean is, suppose we're building an app and we don't really care about like the networking side of it or the UI or the audio. That's fine. We can just outsource that to third-party libraries. But maybe the thing that makes our app unique is that it just does something unique in terms of rendering, right? Well, we can just, again, not worry about anything else, but just focus all of our resources on that rendering section and build something that is exactly tailored to our needs, that is going to be a lot more optimal, most likely, than an existing solution because it's custom and it does what we want the way we want it to. And of course, having all these building blocks leads to a more modular approach to software architecture in general, which I think is really good. So the building blocks can be replaced, as we've shown, but the product is harder to replace. And I think that in 2024, just this whole concept of making stuff out of these building blocks that you've outsourced to third-party libraries is a lot easier than you probably think. Okay, so let's take a look at an example of going through the process of deciding whether or not we want to maybe outsource a building block. So this is something we're going through at the moment actually with Hazel. So Hazel used to use OpenGL and Vulkan, which are rendering APIs. But then we made the decision to drop OpenGL because we were trying to embrace like the next generation of graphics and OpenGL didn't really fit that. So we went with Vulkan only. But now we're at a point where like DirectX 11 and specifically 12 is desirable. Maybe we want to ship on Xbox or we just want to have an API that's more native to Windows. So then if we were to add this support, then what would the engineering cost be if we did this ourselves? And what about maintenance as well? Because it's not just the cost of, I'm going to build this thing and that's it, it's done. It's also like, those of you who might be familiar with rendering know that there's always new stuff being developed, there's always new versions being added, and the API just grows, so you have to also maintain it. And stuff that used to be okay as well with a rendering API might suddenly, in the next version, be like, no, that's a validation error, that you can't do that anymore. So you need to pay that maintenance cost as well. Basically for the rest of your life as well, for the rest of the lifetime of that product. So what are the alternatives? Well, for this specific problem, NVIDIA have one, and it's NVIDIA's rendering hardware interface layer, which abstracts all of those APIs. So it supports Vulkan, DirectX 11 and 12, and it's got lots of extras, which I'm not going to get into. If you guys are familiar with graphics, then those are really nice to have. And I want to point out as well, this is NVIDIA, right? NVIDIA made this library, not just some random guy on GitHub. So, NVIDIA is literally, they're the company that make the hardware that these, Vulkan and DirectX APIs program, right? So clearly they know what they're doing, and the maintenance as well, they're going to know the new features that they're adding and developing to their drivers. So it's just like, it seems perfect, honestly. But is it? Well, no. Because it doesn't support Metal, which is Apple's rendering API, and maybe we want to make a game for PlayStation. Well, we need Sony's rendering API, so they don't support everything. right? But it is open source and it is MIT licensed, so at the very least, it's just an excellent starting point. You know, you can just add support for those other backends, and because there's already like code and an abstraction layer established, it makes that a lot easier than if you just sat down and had to try and design something like this yourself from scratch. Okay, so those are the building blocks that we've talked about. Let's talk about the actual product. So how do we build this actual product on top of the building blocks? Does this mean it's easy to build this because most of the work is done? Well, no, because we still have to build the product. The building blocks themselves just add everything kind of around it, but not the actual product itself. Now, this 90% versus 100% thing, you know, you might look at, you know, for your specific product, you might be in a situation where 90% of the work is in fact like these third-party libraries, and so you only have that 10% at the end to do what you want, and that might not seem like a lot. But if you compare this with the 100% that is not yours, if you go with an existing solution, that last 10% can be really significant. It's like a bit of a balance here, where it's small enough, that 10%, for it to be achievable within some kind of realistic time frame for you, but it's also large enough for you to tailor it exactly to your needs and hopefully still keep it pretty optimal and lean, which is important. So good technical decisions are crucial as well, of course, to this, because you need to evaluate all of these things that you're outsourcing. You need to take a look at these libraries, run it through some tests, maybe talk to someone and see if they're going to be a good fit for you. It's not necessarily disastrous if they're not, because as you can see, we have pivoted, we've changed some of them through real-world experience as well. And that's also a benefit of this, that you can adapt these and change them if you need to. So building the actual product, I like to put this back to data transformation. So there's this concept of like, we have data coming in some format, and then this like little transform block is our code that does something to it, and then that just makes data come out in a different format. I like to draw this comparison just because I think it's really important for us to just remember, and especially if we're trying to overcomplicate things, you know, just to remember the fact that that's really what we're doing in the essence of it. We just need some code to just transform this a little bit. That, I think, also helps us to clearly define like pipelines and workflows, because as I mentioned, we can't just make something that is like super general and fits everything. Instead, we should focus on, okay, this is the way that we're going to do this thing in my solution, instead of trying to fit, you know, maybe someone wants to do it a different way. Bad luck. Here, these are the rules. And that allows you as well to focus on solving the core problem, because all of these adjacencies can just be delegated. If you don't need any specialist solution for like audio, you can just use an existing system. And then also, yeah, building this MVP, right? So minimum viable product. Just always have that at the center of your mind, because that, I think, really helps you to keep things simple. And so to illustrate that as well, I have this thing that I made up like last week called VSDD, Vertical Slice Driven Development. All right, tell your friends, I'm trying to make it a thing. So, you know, a vertical slice is like when you have some kind of milestone or deadline with an emphasis on demonstrating progress across all components of a project. So you're not just working kind of in one section, you're making sure that everything is working across all the areas of your project. And so it allows you really to like look at the complete pipeline of like start to finish, this is what it does, okay, and then go back and refine it as necessary. And you really can't afford to get too deep, so I like to also compare this to like breadth first programming instead of depth first. Instead of going really deep into certain things, like let's just keep it simple, let's just get everything working, and then of course we can go back and add complexity where necessary. So simplicity is obviously very vital for survival when you're trying to make stuff yourself, and that's really important to keep it that way. And what about optimization though? Because a lot of people might think that, okay, well, optimization can add a lot of complexity. Things that otherwise would be simple might need to be more complicated because they have to be really fast. Well, I've found that it turns out computers are fast, right? And the thing is, I think we're used to using existing solutions which have so much overhead and they do so much that when we actually write something ourselves that is simple and does exactly what we need, it's just really fast. Now, of course, that, you know, huge asterisk there, like not in all cases, and there's lots of optimization that's necessary, but it just turned out to be way less than I thought would actually be necessary for this thing to run fast enough. Okay, so what should you do then to conclude this? Should you build your own technology or should you not? Well, I don't know, because I don't know what your situation is. But I just want you to remember, like, this is a really important takeaway, to just make simplicity central to your design. Like, really think about the importance of making something simple. Definitely consider custom solutions, but the thing is, like, you know, I worked on game engines at EA. So therefore, for me to make my own game engine kind of makes sense. It's something I'm familiar with. If you want to potentially build a custom solution on something that you've never done before, that road might look very different. Again, VSDD, trying to make it a thing, so just tell your friends. But just consider that like vertical slice-driven development. Just consider the fact that like you need to make sure that you're always looking at the big picture and you're not just like hyper-focused on one thing. You know, I think that lots of us who work at large companies and large corporations might be so used to just working on one aspect of the product that you might not even understand how everything actually works. And so, like, I encourage some of you to just quit your jobs and try and build your entire product yourselves. Don't tell your bosses, though. And so as you're doing this VSDD, just try and add complexity really slowly and carefully. Just be aware of, like, okay, I'm adding complexity to this part. Is that really necessary? Maybe I can do it in some other way. And finally, I'd like to leave you with a quote. Only hard things are worth doing. If what you are doing is not hard, rethink what you are doing. And thank you. Questions?